We talked in the last set of slides about the difference in population means being a statistic, something that you could use as a random variable to try to estimate what's going on in the population. And we're going to have some practice now with making confidence intervals around the difference in population means. So here are some examples. Some are dumber than the other. But let's say that we have a confidence interval for the difference in the mean number of hairballs between cats and dogs. So imagine we have our computer output and we are 95% confident that the difference is between 5 and 7. How do we write a good sentence that summarizes this estimate of the population parameter? Well, they all start with, we are 95% confident. And remember, this has very specific, special meaning. It says that we have acknowledged that we're not certain what the truth is. We acknowledge that we have a random sample, which is some estimate of the truth. And then we're going to couch that estimate in some sort of uncertainty with a confidence interval. We are 95% confident. And then we can start here. We are 95% confident that the true, I'm wondering if I should write it incorrect. I'll write an incorrect interpretation first. That the true difference in hairballs between cats and dogs is between, and here we put our confidence interval, 5, 7. Now, there's some elements in here that are missing. We have this idea that we're 95% confident. We've stressed here that we have this true or this population difference, but we've forgotten to include something very important, and that is the directionality. Who has more, cats or dogs? You can't tell from this interpretation. We also didn't include in here the units. Units are really important. Is it hairballs per year? Is it hairballs per day? Totally different. So if we erase this, let's see if we can erase all this at once. So we are 95% confident that on average, remember, we're talking about the difference in population means here. So we need to say on the average. Now, how can we include directionality? Cats have 10, dogs have 4. So that on the average, cats have between 5 and 7 more, there's our directionality, more hairballs per year, there's our units, than dogs. So let's check to see if all our elements are there. We are 95% confident. That's our alpha level, or the degree of certainty that we have. And then we have on the average, which stresses we're talking about the mean of a continuous variable. On the average, cats have between 5 to 7 more. There's our directionality. And then hairballs per year, there's our units, than dogs. Good. So let's look at the next one. Here's a study of 2 weightlifting supplements, and we're looking at the average muscle gain per year. So we can say we are 95% confident that on the average, people on creatine, or people taking creatine, gain, here's our confidence interval. Notice what's in the middle of that CI would be the number 2, right? The number 2. The confidence interval is the point estimate plus or minus 2 times the standard error. So that has to be right in the middle. People on creatine gain 2 kilograms per year more than people on a placebo. You can also double check that too. If we look, this treatment group gained 4, this control group gained 2. Great. A study about hours of video games played per week finds a mean difference, boys minus girls, of -10 hours. So here's the CI. This is a little bit of a twist. We got negative signs all the way around. Boys minus girls is -10. So for the correct interpretation, again, we are 95% confident on average. On average. Who plays more? The girls. Girls play 10 more hours per week than boys. And we can write 95% CI 8 to 12. So the construction of this sentence is a little different than the one we did before, but just make sure that all the elements are there. You have your 95% confidence. You're saying on the average. You're saying who is more, girls or boys? That's the directionality. You're saying how much more? That's the magnitude. And then you're giving your confidence interval here. And then you have your units, hours per week. All right, let's look at this last one. This last one I made up. Let's say for your applied learning experience, you wanted to do an intervention to see if you could increase walking in a community. What could you do as a public health student to increase walking? We might put up advertisements for walking. You might try to incentivize physical activity by giving away money for people who walk the most. You might think about the built environment, then the socio-ecological model of health and try to build new sidewalks or try to put in lights or crossing guards or something like this. There's lots of different things you could do to try to increase how much people walk per day. So let's say you do an intervention and this is the confidence interval that you get. -16 to +24 minutes per day of walking. Now, if we just plug in the sentence that we just did, this sort of construction, we would say, we are 95% confident that on the average, people in this target community, people who get this intervention, they walk between 16 minutes a day less and 24 minutes a day more than people who didn't get the intervention. So 16 minutes a day less to 24 minutes a day more. This confidence interval is very interesting. It's different than the other ones we've seen because look what's somewhere in the middle of this CI. 0. Our data are consistent with the fact that your intervention did nothing at all. If this was actually your project and you did this, here's the confidence interval you got, you would be really disappointed. You started this project because you didn't know if your intervention worked or not. You collect some data and you find out, well, either my intervention might work, 24, or it might not work, -16. It might be so bad that you cause people to walk less. They want to stay home so they could get away from your intervention. So we're going to see what this means when my confidence interval for a difference in means includes 0, because it means we have no evidence that there's a difference. There's no evidence that these two groups are different. The data are consistent with the means being equal to each other. And we'll see how this can lead to the definition of what's called statistical significance. Stay tuned.